Welcome back, everyone. Happy to have you around. Tonight, rather, we will be looking at getting some actual related design work done. Uh, had a lot of thoughts and ideas in the last episode, and I don't feel like I got a lot accomplished. So after doing a bunch of research this past week, getting some guidelines and ideas and concepts down, I'm kind of forming an image of what I really want in my head. So, with that, we'll go ahead and get started here. The one thing I did want to mention though is I also spent a lot of time trying to look for like a simple flow analysis type software program online to kind of give me some indications of whether or not this concept and idea will even work. And unfortunately, I didn't find anything that was applicable to what I really wanted to do. So, with that said, I'll probably be looking more towards getting into um, actually checking out some other people's work, kind of related to it, but not exactly, and kind of building my own mental proof of concept on that, and maybe even soon I'll be able to do some actual testing with that. The other thing, an announcement that I wanted to make was that starting uh, this week, and I will be creating some SolidWorks shorts, is what I'm going to call the series, and that will be more geared towards a simple execution of commands and things within the SolidWorks framework as tutorials. I've been getting some feedback regarding that, and that seems to be a large portion of what people that actually do SolidWorks want to see, because there's not a lot of that out there, if any. So I'm expecting these types of tutorials to last between 2 to 5 minutes on average, and then ones that commands and techniques that require more I'll max it out at 15 minutes. So be looking forward to that coming up soon. Should be starting next week. I'm hoping to get a whole bunch of them done and release them like every day or every week or every couple days. We'll see how it goes. Um, because the me wanting to get some things built and stuff. I mean, anything outdoors, like for the shed or for the meat machine that I made or designed rather. The window's pretty much closed up for that as it's getting really frigid out here and cold. Um, plus, you know, there's always the money aspect of it. So hopefully next year we'll be able to see some actual builds, and hopefully I can get the GoPro out that I got, and hopefully find some just build it series or projects that I can do as well to kind of add a little bit more flavor and whatnot, and not have these live streams which are 2.5 hours long. So without any further ado, uh, I wanted to show that I actually did get something pretty awesome. I contacted the manufacturer for the generator that I wanted to use that we talked about last week, and I contacted them and said, hey, I need a model so I can better design for. And they sent me a link, and this is what I have. So pretty excited about that. Gives me a lot of good dimensional material to work off of. Uh, if you look though, like if I turn off some of the features, there's a lot of the internals are not there, which is kind of disappointing. I was hoping I could have some the stator shaft, coil windings, and things of that nature, but they generally leave that type of stuff out. Anything that's in-house design and has a lot of hush hush secrecy, so people don't just go out and copy their designs and whatnot. So this will come into play a little bit later on. And what I'm going to do is pull up where we're at. Let's see. I think that's the one I want. Yeah, so very rudimentary, very simple. And I realized pretty early on that this is not going to work. So, what I'm going to do is come up with a design that I am positively sure that will work. So this will be inevitably change. So with that all said, I think the first thing that I want to do is I'm going to go ahead and close this one out, because what I'll probably do is just dump that assembly and just create a new one. So I want to start a new part. And what I'm going to do is start off with basically a block. And I'm going to see whether or not if I can do a prototype out of plastic, like have it 3D printed by somebody and then pay them. I'm not 100% sure. But inevitably I'll want it, I think aluminum, machined aluminum. So, and hello Paladin, thank you for stopping by. Yeah, this is going to be an insane project, I think. So, let's see here. Oh, normal 2, that's what I want. Okay. So let me get some dimensions on here. Now this is all based off of one of the most recommended and common airflow systems from utilizing a VivaSun, basically growing tent for consolidating rigs and putting rigs in. So I'm working off an 8-inch ductwork, which some have 2, plus some 6-inch. So I'm going to go with a standard 8-inch size and go from there. So for this, we're going to go with, actually, yeah, this is going to be different because I'm going to actually design 1/2 of it, and 2 halves will make the complete assembly based on what I'm going for. So let's do this. So if we have 8 inches, and in order to increase, there's a couple different techniques that are used in the industry. Basically, they have, if you guys are familiar with wind turbines or even airplanes, the Airfoil Design, it basically is like a teardrop shape. So what they do is air coming in, or pressure or steam, because that's kind of what I'm basing this model off of. Steam comes in and flows over this airfoil, which creates a pressure differential and causes lift, which in turn causes it to spin, because they have a whole bunch of these. Now, the next phase is a stationary phase where the same concept is in reverse. So what that does is that the difference between the pressure between the first phase and the second phase, it actually increases its velocity, like gives it some energy back. And then they do that through several stages, and all of that is rotating the shaft, and then it empties into an exhaust. So that's kind of the concept I'm going with. And if you can't visualize it in your mind, you'll see. I'll get to the rotor. That's one of my goals after getting some simplified design here done. So what I'm going to do is, if I'm considering an 8-inch diameter airflow system, I'm going to go with 5 inches on the block. And I initially had, I believe it was a 24-inch or an 18-inch from the main on each side where it go where the 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 fans, I'm going to call them fans, the turbine blades, I guess would be a better more appropriate term, all that to fit in. I haven't decided on how many I want, their spacing, the size. So this main dimension here will change once I get more and more in depth into this design. So for right now, I'm going to do a 24-inch overall. And let's fit that to the screen. And we're just going to go ahead and extrude that mid-plane, which it takes it from, it counts whatever plane I put the sketch on as the midpoint, so it expands like this. And we're going to make that square. No. I'm doing 1/2, so this needs, I'm going to go 10 inches on this. Yeah. And we can actually edit the material and make it aluminum. Or, well, an aluminum alloy. And I think 1060 would be the one that I would most want for this. Alright, so my first option, or not option, but my first criteria will be to, whoops, hello, can I, oh, yeah. Actually, no, I don't want to do it that way. Let's do it mid-plane. My first task, that's what I want to say, is establishing the airflow path. So what I'm going to do here, halfway, and if I'm going with 8 inches for the airflow, then I want my anything that houses the ducts, I want 8 inches to be my internal diameter for the airflow. Now, given that I don't quite know off the top of my head how big my blades are going to be, I'm going to go with, let's go with 9 inches to start, and then I can always modify that later on down the road. And then I think what I'm going to go ahead and do is put in an 8-inch as a reference. And honestly, I could probably do 7. That way there's a slight reduction in, oh no, that's not what I want to do for construction. That's what I want to do. Goodness gracious. There's a slight reduction, which would reduce volume but increase velocity, if I remember right. Been a while since I did any studying on that, in depth rather. Okay, now the other thing is I will most likely have to have supports for the shaft internal, and I have an idea of how I want to do that with bearings. Let's see here, and the ends will have the shaft connected to the motors. So, alright, let's do this. Let's do an extruded cut. Well, I wanted to see it like these, and we're going to go mid-plane on that. And I think I want to go 23 inches, leave it an inch out. And then, of course, our our shaft diameter. Let me bring this bad boy up so I can look at this again. Oh, that's not the one. I need it to be this one. I just want to open that so I can make sure the my understanding was it's 0.874. 87401. Okay, 187. Oh, that's the chord length. Okay. Oh, excuse me. Let's do this. We'll create a sketch on that. Okay. Is it not working? Let's try doing that first and then selecting. Oh, it will not do that face. So let's go and grab the front plane. And I'm going to try and grab that center too. Yep, that's the. This way we can verify our. Cordial. So that makes that bad boy a radius of 0.437. Whoops, hello. Let's just do it this way. 0.874. Okay, so 0.874 is actually, okay, I did remember that right. And I'll keep this up in the background just in case if I need to reference it again. So 0.874. So what I'm going to have to do here is look for a bearing. Let's try McMaster car here. And bearing. Here we go. Ball bearings. Oh, wait. What was that? Bearing housing? No, because I'm going to make that out of this. Yeah, ball bearings. Wider than a standard. These are rugged bearings for good heavy loads at low speeds. Higher loads than stainless steel and plastic. With corrosion, I don't really think I need a corrosion resistant. Oh, I like the flange ball bearings. Could press fit those in really easily. You know, I think that's what I want. So 874 would be a 7/8 for shaft diameter. Let's see if they have a 7/8. They do not. That's a little sad. Oh, there we go. Let me just isolate those. Oh, housing ID. Okay, that's not what I... No. That's not what I want. Housing ID. I want diameter, shaft diameter. Here we go. 5/8 and then 3/4. Okay, that's a little annoying. Okay, I guess we're not using those. Wow, they don't have... Here we go. Let's go from the top here. 7/8 with oh wait, no, that's wrong. because I have to patch into that key. So this can be whatever I want it to be. So I'm assuming 1 inch for the shaft diameter. And do I want it sealed? And that'll have a 2-inch housing inside diameter. Okay. This looks pretty good, actually. Alright, let's grab that and put it in the folder. Let's see, mining. Oh, no, that's my actual miners. Designs. CryptoGenerator. Paste. So housing ID is 2. Okay, so let's go back to the main here. So this means I'm going to, we'll do this. We'll go with, let's go with the top here, and we're going to create a sketch on this bad boy. And I'm actually gonna, oh, what was the thickness on that again? 1.344 is the material. Oh no. Flange has a 2.125. Okay. And WD, I need the, let me see what this says. I need this information here. No. 0.5 minus 0.063. Okay. All right. So 0.5 minus 0.063, 0.437. Okay. Well, 0.065 is 437. So as long as this is a 1/2 inch or more, it'll be fine. That thickness, and it should be 1 inch right now because I did 23 inches for this in internal cut. All right. Let's get this bad boy horizontal, infinite length there. Make these. Okay, let's get on it. Symmetric. This, my goodness, does not want to cooperate today. Collinear. Come on. So I'm going to assume I'm going to need at least 1 inch, maybe. And that data indicated that the overall 2 and 2.125, and if they're going to be pressed in, which I'm assuming they will. Wait. What's going on here? I want the internal to be 1 inch. Isn't that what I selected? Yeah, shaft diameter 1 inch. Okay, that's right. So what is this? Oh, that's, okay, 2 inch, got it. Okay. 0.002. So I want a press fit for 2 inch diameter housing, and it can be 2.002. so 2 inches. I'll have to, oh, for Pete's sake. It really just, I don't know why it does that. Alright, so if I want an inch clearance on each side, we're going to make these 4 inches. And I'm going to extrude those up. At least, so I'll be kind of doing a half and half. Obviously, the next one will be a mirror of this, but with this cut out of it. So if we go, I believe 3 inches on this one now, because I'll be putting it centered on this point here. Yeah, I think that's how I want to do it. And then on this plane here, I'm going to create a sketch. It's going to be vertical there. I want this to be on midpoint. I want this to have a 3-inch diameter. Yes, that's what I want. Okay. This is really a lot taller than I anticipated. So, oh, that's why. I can fix that. Okay. Through all both. And I need to shorten this a little bit. So it'll be 2-inch plus 1. It's half, so that should be 2.50. Yes. No, that still isn't right. Half of 2 is 1. Plus, it should be 2 inches. Why am I having difficulty mathing today? I don't get it. Alright, let's make some pretty curves here. That does not look right. But I don't like that. Yeah, we'll do it like that. It's not, oh wait, does that leave? That does not leave much there. Let's do 1.5 instead. Alright, I'm good with that. And then we're going to go ahead and do the same thing on these curves to give them more strength. Goodness. And I think 0.25 is about, yeah. That's what I'll get out of that. Now I'm not looking to make this super strong because the amount of pressure that this thing will sustain will not be enough to where I really have to make this out of like crazy iron. I mean, we're looking at a pressure system that's going to be effectively 1/10 that of atmospheric pressure based off the specs on the inline duct fan. So that I showed last week. So now I want another feature centered. Actually, I'm going to have 2 shafts. Yeah, I'm going to have 2 shafts for this. Let's think about this. I really hate the square shit. I am going to make that look much prettier, so. But this is just rudimentary design work here to get kind of where I'm going with this. And this is just a housing for right now. So each one of these Alright, let's look at this. I have 23 inches, or 24 total. So from here to here, oh my goodness, should be a ½ inch, and it is. And then that means I got ½ inch all the way around. Okay, I'm happy with that. And I'm going to want, so I could have either I need a scoop in here, something that diverts, that splits the air coming in 2 ways. So like a Y splitter in here. But I'll need room for that. You know, let me go ahead and save this part. I'm going to call this, what am I going to call this? Airflow chamber base, sounds good. And then what I also want is to be able to fasten it together, but don't need to worry about that just yet. Probably need a small gasket. Which, not worried about that just yet as well. So we'll see. We're going to keep going with it here. Okay, so I do need a point of origin to make the shaft. Alright, so what I'm looking at here is I'm going to do a little sketch to kind of get me to a point where things look fairly nice. So if I have that, and okay, this is kind of what I'm looking at, and what I'm looking to do. Let me bring back. Where is it? Where's the diverter? I made it 10 inches, but is this the one I want? Yeah, this is what I did last. So I'm looking to bring that back in. What did I do here? Oh, okay. Yeah, that's what I did. Yeah, that was really complicated to do. Okay. But I want that to be 8 inch, so I really need to modify this to make it right. If I do a ½ inch thickness on the wall, but I only need a section of it. Okay, I'm not gonna work. I'm not gonna try and modify this. So for here, inches. That for construction, and I want that for construction as well. It's just giving me some concepts. So what does that give me between here and here? 7.5 minus a 1/2 inch for these walls. So my first one okay, let's look at this. Oh, I wanted to do it this way. And those are going to be 0.5. Make these two exactly the same. This gives me my spacing, because I need to put the shaft, the rotor, the turbine fan thing is going to be attached to the shaft on this. So every other one of these will be part of the rotor. So, 1/2 inch, is that going to be enough? That's the thing I need to figure out. Alright, for now, let's leave that alone, because I think I need to have some design on the other component here. So let me bring up a new thing here. So let's see, how do I want that to be? I think I want a front plane. And I need a teardrop, well, kind of a teardrop shape. I think that's what yeah. There are many different kinds, and oh, here's a turbo fan blade. And a turbine blade. That's more along the lines, almost like a Nike swoop. Very similar to this. Cord line, chamber, angle of attack. High lift, low speed. High lift, low speed. Low camber. No. It's more for airplanes, but it's the same principle in this design. Nah, this is not what I want. Maybe when? No, well. Okay, none of this is freaking helpful. So many different ways to do it. Wonder if we have a steam turbine airfoil. There we go. Ooh, that is crazy. That's really close to what I'm looking at. Oh, there's a gallery of it. Ah, it doesn't blow up. Okay. So it has a swoop twist. So, okay. Got to figure out how to do this simplistically. All right. I think what I'm going to do is I'm just going to start throwing something together here. Actually, let's make this along. Yes, horizontal. And we're going to try, let's see, where am I at? No, that's way too big. It's 2.75. That puts this at 0.375. Let's try that. And we'll do 0.1. Ooh, hello. It's not exactly what I was hoping for here. So if I have this is tangent to that, and this is tangent to that. And let's see. Whoops, hello. And then I need another one. Oops, oops. That envelops both of those. Tangent to that. That one's... Let's try that again. Tangent to that. There we go. If I make... Let's see, what does that look like? Oh my goodness gracious. I want it up here. There we go. Somewhat of an overlapping feature. That's really thick. It needs to be much, much thinner than that. And if I remember right, those had like a twist in them, but I'm not really sure I can. I'd probably have to create a mesh, and I am not familiar with those. But I guess it could be on a curve. That might work. Let me see here. just start getting rid of some stuff here. That still feels really thick though. And it's not a bad looking shape, honestly. Okay, now if I look at that and now this will be oops, come on. Air will hit here. Out, and then the next one will go this way. All right, let's just extrude that. Let's see if I want, so 8 inches, and I want as much carriage as I can. So it's going to come in through the opening and expand up and start hitting these things. So I want as much surface area as I can. Let's start off with 1 inch. We'll do it mid-plane. Alright, then another part. From plane here. A circle. Nine. So if that's the way I want it put in, it would be more like this, I think. Nine inches. Alright, that's okay. That's going to be like that for a second. And just do 1 inch on that. Now, let me make this into a assembly here. Oh, damn it, that's not what I meant to do. Okay. That's my front. Okay, now I want to insert airfoil here. And I want that. Needs to be at least like something like that. No. I'm doing something ain't right here. No. Okay, so if I do one straight up and down, all right. So let's do this. Was I forgot 2 inches? 1 inch. Okay. So let's do this. Let's go. Actually, I can do it in this assembly. Make it a little easier. Just do a little sketch here. We'll do a center line. Going from here to, oh goodness, really? Okay, okay. Now, can I put the origin here? Yep, I can. And let's see here. Okay. Then I want this to be parallel. Okay. And if I do a polar array, that should work. What was I at? Assembly, circular component pattern to direction. Can I do? I don't want to do the face. I don't like that. Let's do that in case if I have to throw it. Components to pattern. Equal spacing. 60 of them perhaps. I think I like that number. I'm going to have to tweak some of this up a little bit. Obviously. Because right now they're just floating. And they'll have to come in or down a little bit. So let's modify this. Let's do that. There we go. That's better. So we have an inner ring. So from here to here needs to be as close to 8 inches as possible. And we're at 8.5. Okay. I don't think this is right. I think it has to have a curl in it. Oh no, that'll work. If air's coming in through this way, it's going to push it out. So I'll have to make accommodations for that so that it allows the air out. So that's going to be interesting as well. Let's see how much time we are on this. Okay, good. And honestly, that needs to be like, I'll have to modify this. Let's see here. Actually, what I can do is move this in. What is this distance here? Can I get that? My name is intersect. Well, I know they intersect, but I want the dimension. Oh, Lord. Okay. From here to here, maybe. 0.08. Now, how are those going to get inserted and affixed? That's the other thing I'll have to figure out. Maybe I can just do a swept design where they just slide in and somehow it clamps it together of sorts. Of course, that'll add weight. Anyway, I still think those are pretty beefy. I might even need to thin them out a little bit more. Because that's a lot of mass to move, honestly. So, looks like I had a little stutter. Did anybody notice a stutter? I don't know. Sometimes it throws stuff on my end that you guys are not experiencing. Alright, so with this initial concept, let's look at make an assembly from this. And this, I'm going to call this the, actually this will be the main assembly. Actually, this is, okay, we'll do, whoops, chamber. Yes, and then I need to make another assembly out of that assembly. Because this will have more, this will have the piece that goes over the top of it, etc., etc. So this will actually have, I can actually put the bearings in here. Did I save the bearings? I did, but I don't know where I saved them. Let me find that real quick. Huh. Where in the hell did I put them? Oh, there it is. this right here. Good Lord have mercy. That's how that's set for 2-inch shaft. Why is it so goddamn big? What did I freaking do here? I really screwed up something. Oh. It's supposed to be 2. Holy Christ. I might change this to where it actually is 1/2, yeah. 1/2, and it just sandwiches together and bolts so it encompasses the bearing. Which means it wouldn't have to be a press fit. It could just be a clamped in fit, if that would work. Alright. Definitely some modifications coming in the future. That's for damn sure. I don't know why it does that. That's annoying. Come on. Oh, nope, nope, nope. It's not what I meant to say. That. Why is it trying to... Jesus, really? This should mate to this that way. I don't know why it kept giving me the other thing. That's just dumb. Alright, we'll save this. That's the air intake chamber sub-assembly, and then I'm going to make another assembly from this. And I'm going to save that as the actually, I'm just going to overwrite this because none of that applies anyway. Alright, now let's bring in... Nope. There, that's what I want. And I need to swing on the Y. Yes, that one will go this way. And if we do this again, I'm going to insert another one of those in here. And this one will go this way. And then the next one, so essentially, the next one will have the curve going this way. See if I can bring that in as a example. So I can show you what that'll look like here. Whoops. And these will be stationary. So if we look at this from a top-down perspective, and I don't think these are, I think these are rotary. Oh, come on. They don't, oh, there we go. That's going to be like right up to here. Yeah, so if I get this one as really close to straight up and down as I can, and then I put that one. So basically, that's what you're going to see. But of course, as many all the way around. And then we'll have another one of these here, and then another stationary here, so on and so forth. And then I need I'm going to need a chamber for air. No, not for each one. I won't need that. It'll continue forward, and then I have an exhaust collection on the aft here. That's what we'll do. Okay, that's okay. Yeah. Hopefully this is making sense for those of you that are watching and listening to me stumble through my thought process. So, and I'm definitely gonna make this prettier. This is just, like I said, for concept. So right now I think I'm at a good point where I'm going to do a leg stretch and take a few minutes to use the restroom and all that good stuff. So stay tuned. I'll be right back in a few minutes. Don't go anywhere. All right, back everybody. Right. Let's see here. Thank you, Avast. Let's see. All right, I think the next step then. Okay, yeah. So I'm gonna need. I like this idea. This is working out pretty good. So we're gonna go ahead and put those pieces in and extrude it down. Excuse me. All right, so let's go ahead and get my center done. So I can bring this sketch back. Actually, I should be able to extrude it as is. So let's go ahead and extrude that. And it's going to want to go up, so I want to point it back the other way. And we're going to go up to, should be up to next. And see how that does that, just nice and pretty like. All right. And if I had put that in before this cut extrusion, no, before this cut extrusion, so I should be able to do this. Move that and boom. I got my cuts where I want them. Alright, let's see here now. I don't want... Oh, this is going to be a little bit different here. So I need an opening. Need an opening for this. For that 8 inches. Should be able to make that concentric. Yes, thank you. Appreciate you. Let's have a dimension here. That really doesn't matter. 8 inches. Okay. Now, where does that put me? You know what I'm going to do? Yeah, that's okay. That's good. All right. So I'm going to cut that in half. And let's remove the unnecessary. And we're going to make this almost a partial wagon wheel. Alright, so let's offset this in. Doing this as a stationary inlet. Let's offset that to 0.25. Reverse that. And I believe I want this base to be for construction. And I want this here to here. And I'm going to offset that. Let's do that. Bidirectional. And I want another one here to here. And from here to here. And those I think I'm going to put on, let's do 45s on those. And we'll offset those like the other ones. Can I do both? Yes, I can. All right. Okay. So I want this section to cut out, this section to cut out. All right. Trimming this stuff up is so tricky sometimes. Okay, so this triangle is going to be a hole. I may have to rethink this. That is going to be a hole. And I want this one and this one. Is that going to be the same? Oh, oops. Shit, I forgot about that part. Okay, let me make sure all that's it should be. Okay. Yeah. Okay. Boom. That's fine like that. Just keeps everything happy. Okay, I'm good with that. Okay, we're good there. Now, are these equal sized? Oh, my brain. Should be able to, there we go, yep. Okay, now this has to be trimmed out. Unsolvable. Nope, that wasn't it. Why is that? Oh, there's too many. Can I make this driven? That doesn't do anything. I'm a little bit confused of what's going on here. Why is it doing this? Okay, and then this one is driving. There we go. Okay, that's fixed. There we go. Yep. I think that's what I want. Let's do an extruded cut and see if the magic is real. Mid plane. And then I want that to go through both of those. Hopefully that goes underneath. Okay, I'm going to have to account for that as well. Okay, so let me get back into Sketch. Equals, and then we can make this boom, boom. I don't know why it's okay. Apparently it lost a relationship with what I said it before. Well, that's fine. That's fine. Easy fix. Alright, now let's do this again. And plane. Okay, that's not doing what I want. Hello? Oh, I came off of this. Okay. Alright, let's get rid of this. Whoops, hello. Let's come off here. Let's extend these to where they need to be. We're okay there. Trim these out. That should be what I want. Should be what I'm looking for. And of course, we'll make these, we'll sharpen those up so there's a lot less air resistance coming in. Or we'll round it. That way it's not a block of air that stops stuff. You can just slip through. At least that's what the next goal will be. Alright, so that is our inlet with shaft support. So the next piece that has to go in there, let's see something here. This would be the air chamber. So my shaft connector will connect to this piece. It'll be two independent shafts, so there's not one going all the way through. That'll make disassembly much easier, I believe. Now let's see what that looks like here. Okay, that's okay. So I do need to modify so those fans are internal to this. And this looks really thick here. I think I may need to slim that down a little bit. Let's go back to that. So I believe I have just a quarter. Yeah, quarter-inch. So that that is why. Okay. How can I fix that without having to redraw the whole damn thing? Oh, here we go. I think it was 9, wasn't it? Yeah, there we go. That's much better. That's the ticket. Yeah, okay. That's what I'm looking for. Oh, I can get rid of this. So I'm going to have to make those stationary a different way. I think I'll make them as an insert, but they're not, they'll slip along the shaft, but they're not going to be connected to the shaft, so they'll have to be secured to the sidewall. At least that's what it's looking like. And I do need to fix that so that it's inset. Okay, let's think about this here. This will need a bearing system as well. And I think I can duplicate that. Nope, that's not what I want. Oh, shit. I need this. Let's see if I do. Let's go ahead and bring that in here. Okay, that works. Now these might not be the right. Oh, hello. That was freaky. It's going to do that again. Now, honestly, these are the wrong bearings, I'm pretty sure, because I won't. These can be press fit the way I've got this constructed now. these would have to be bolted in. But I guess I could make this feature through here. We would also have to have this cutout in the top. I have to think about that. Oh, you know what else I didn't think about? Is this will have to be half as thick as this for when I put the second piece over the top, so that it maintains the same thickness all the way around. These ones will be double thick. Let me fix that real quick. There we go. That's better. That even it gives me more airflow. A little bit more than my goal was. Should be fine. So I think I want to move this up here. But I like to keep all my fillets after everything else, just so it's a little bit more easy to just figure out which fillet goes with what. Because I remember what I did here. I remember what I did here, and I know what I'm gonna do next. So I don't like that this is like that, but because this is going to be as thick as this plus this, which is it's fine. It just looks funky because I know it's not as thick as these, but it's actually thicker. So we're okay there. We're okay. Let's save that bad boy out. So far, so good. Alright. So I'm going to need a shaft with sprocket connections. Not sprocket, with connectors on this bad boy for the shaft itself. No, that's not what I meant. Alright, let's think about this. It would be more like a spindle. That's what it would be. So these bearings have to be put on the shaft. They won't be press fit in here. How much distance do I have from here to here? Very important. 7 inches. And then from here to here, hopefully it's closer to 16. Oh, no. 8 inches. Yeah, this is going to be tricky coming up with a system of putting it together, that means this feature is just going to have to go away. That won't work because I want to be able to pop the shaft right out. So let's go back into here. Oop, wrong one. And so these can go away. And that can go away. Ooh, nope, that's not what I was wanting to do. Can I move this? No, I can't. That's for that, that's for that. It won't let me delete it. Ah, don't delete child features. That's what I want. Okay, there we go. Been a long time since I needed to do that. Okay. Oh yeah, we're gonna have to fix this sketch because it's like I don't understand what you want. Oh, because let's see here. No. Make that viewable. That way we can put that on the same. Can I do? Yeah, there we go. And we'll just. Yeah, that is arbitrary. There we go. Hide that back. Alright, now we're back on track. Yeah, I'm gonna have to do it this way. This is actually better because then I can literally do two halves and put them together. So in fact, I could actually do that right now. This is the air intake subassembly. Has that in it. So put that in. Whoops, spin this around. Actually, I'd rather do mid-plane to mid-plane here. Oh, zoom out and see what that is. Yep, right plane, right plane. There we go. Ah, there will be a different one because one has to have the intake. So that will work. Let's do this instead. Can actually make this really easy. If I go to the folder where it's at, I can just copy that, rename it, and do a slight modification so it's actually 2 pieces. CryptoGenerator, and we'll rename it to top. Easy peasy, lemon squeezy. Now, Now what I can do is browse for the newly created part, chamber top, bring that bad boy in, and I don't know why it's doing that. Doesn't make sense. Actually, I can do this. There we go. Reverse it. And then we'll go right plane to right plane. Bam. Done. Yeah, I don't know why it does this. Makes no sense. Something to do with the it's got to be a driver with probably a setting in here where when I turn something down, it throws it back. Performance. Made animations. That's fine. Maybe image quality. Here we go. Shade and draft, wireframe and high quality resolution. We can actually drag that down. Maybe, hopefully that'll, there we go. Oh, nope, it didn't. Okay. Yeah, I don't know why it does that. Good old SolidWorks thing. Sometimes it'll even persist if I close it out and open it back up. Just one of those things I never understood why it does that. It just, every once in a while it does that stuff. Let's see, and is that the one I want? Intake subassembly? No, that's that piece. That's not what I want. Air chamber, there we go. Yeah, now it's fine. I don't know. Alright, if I cut it. There, you can see what I was meaning when these 2 pieces had to come together to make it be the same thickness as everything else. And then up here is where we'll put the air intake something on. Actually, I kind of did that premature. I should have done all the blades first and then made the copy. You know, I'll probably do that. I'll make sure that's done. So let me do that real quick here. I'm going to make these nice and pretty. That might be too much because that's half. No, that's not bad. There. Oh, I want all of those. Just on the front edge. I don't need the back edge. Sometimes I feel like Bob Ross. I think some of my methodologies kind of reflect some of his characterizations. Do something, and instead of it being a mistake, it's a happy little accident. Something you do that you didn't mean to, but it ends up turning out a little bit better than what you previously thought. Oops, come on. Let's get them all. And we'll just put this little curve next to this guy. There, that should smooth that out a bit. Now I can save that. And so that really didn't take me that long. I can do the same thing to the other one. Top. And should be exactly the same if I put it on like this. Yep. Let's do that. And it should have held the same. No, I guess it didn't. Surprise, surprise. Oh, you know, I probably should have these as well. That would make it look much prettier. Oh, for Pete's sake, I can't see that one. Alright, we won't mess with those right now. I'll do that off camera. Oh. No, I don't want to do that whole thing either. So I don't need the back side done, just the top side. Oh, that's a new feature. At least for me. Make that shit easy then. So I don't have to like try and... Yeah. Oh, that's much nicer. Yeah, let's do it that way. Bloop. Huh. Either that's a feature I've never seen before up until now, or it's a feature that's been there and I never stumbled upon it. Honestly. Do I want the same type of exit? We'll deal with that later. We'll deal with that after the fact. Because I'm pretty sure that I'm pretty sure I know what I want for as far as exhaust goes. I can hide those. But I definitely want a much better shape than just a box. Even though there's nothing wrong with it, it just looks tacky to me. Alright, so doing that. That's what I want so far. Alright, that is about enough time for this episode. What I believe I'll want to concentrate on next week is getting this refined, as well as, if there's enough time, because this is going to take a little bit of forethought to figure out how to do this assembly with a shaft and all that stuff. So hopefully I can get this fairly well ironed out and work on the stationary part of it, and then go from there. So yeah. Oh, I think that's we're gonna call that good. It's actually a pretty decent episode where I got quite a lot more done than I did last time. I'm very happy with that. Alright, let's close all these ones out that I don't need right now. We'll just save all documents. Why not? Alright, everybody. Thank you so much for watching. I will see you the next week, and we'll continue this wonderful project. And I also will, like I said at the beginning of the video, um, look forward to seeing some short tutorial type clips, and we'll see how it goes. Thank you again, everybody, for watching, and we'll catch y'all later. Everybody have a great night.